Hi, this is Mrs. Lloyd for Lesson 2-2, iReady for Math 7, Solving Problems with Unit Rates for Ratios with Two Fractions. Our learning targets: find unit rates for ratios with fractions, solve problems involving ratios with fractions. On page 37, Julio and Kyle hike along the same trail. Julio records his speed on his phone. Kyle hikes the first 6 miles in 2 hours. Look on the phone. Do you see that Julio hikes the first 1/2 mile of the trail in 1/4 hour? What do you think the question's going to be? So again, Kyle hikes the first 6 miles in 2 hours. Who hikes more quickly? What could we do? I like to think in terms of miles per hour, so that's the way I'm going to approach it. Kyle is 6 miles in 2 hours. So what is his miles per hour? 6 divided by 2 is 3 miles an hour. 1 hour, you could say, or 3 miles per hour. Some people like to use miles per hour, mph. Julio hikes the first 1/2 mile in 1/4 hour. 1/2 mile in 1/4 hour. So that's the same thing as 1/2 divided by 1/4, or 1/2 times 4/1. 1 times 4 is 4, 2 times 1 is 2, and 4 divided by 2 is 2. 2 miles per hour. Who hikes more quickly? Kyle hikes about quicker. That wasn't bad. Let's look at the model it. Looks like in the model it, they did exactly what we did. On page 39, look at the second model it. The fraction 1/2 divided by 1/4 describes Julio's speed in miles per hour. What fraction describes Julio's speed in hours per mile? So a lot of times when we're looking at unit rates, we have to look at the order that the words are given to us, or the units. Hours per mile would be 1/4 to 1/2, which is 1/4 divided by 1/2, which is also 1/4 times the reciprocal, 2/1, which is 2/4. Simplify that fraction to 1/2 hour per mile. And sometimes that's a good way to look at it. It takes 1/2 of an hour to go 1 mile. Number 4, the fraction 6/2 describes Kyle's speed in miles per hour. What fraction would describe Kyle's speed in hours per mile? What is his speed in hours per mile? So I think you can do that one pretty quickly. 2/6 would be hours per mile. And in this case, 2 doesn't divide by 6, but 2/6 would simplify to 1/3 hour per mile. Do you need a different strategy to find each speed because one involves fractions? You might think it's a different strategy, but you're doing the same thing whether it is fractions or whole numbers. On page 40, a penguin walks south. It completes the first 1/3 mile in 1/5 hour and continues walking at the same rate. What is the penguin's speed in miles per hour? So let's look what it wants. Miles per hour. 1/3 of a mile. 1/5 of an hour. That would be miles per hour. Go ahead and work that out. I'll give you a head start. You could say 5/3 miles per hour, but in this case, a mixed number is probably a more clear answer, 1 2/3 miles per hour. Number 8. A tree shades an area of 7.5 meters squared. In a scale drawing, the tree shades an area of 12.5 centimeters squared. In the scale drawing, how many square centimeters represent 1 square meter? So square centimeters to 1 square meter. So in this case, we need 12.5 over 7.5. Look at your wording. We want 1 meter squared, and this is our centimeters squared, meters squared. And so when I know I need 1 meter squared, that needs to be in the denominator. So we could pick up a calculator, but I don't think we need to. Let's divide this. We need to change our mixed numbers into improper. 2 times 12 is 24, plus 1 is 25. So we could change that to 25 halves. 2 times 7 is 14, plus 1, 15 halves. And now I can multiply by the reciprocal. Cross simplification allows me to cancel these 2's because 2 divided by 2 is 1. So I have 25 over 15, and that simplifies to, both divide by 5, 5/3. Use the words, makes your problem a whole lot easier. And number 9. Delilah is making a piñata with her mother. They mix paste for attaching the newspaper strips to the cardboard frame. For every 1 2/3 cups of water, they use 2.5 cups of flour. How much flour do Delilah and her mother need for each cup of water? So we're looking for flour per cup of water. So flour is 2.5 per cup of water, 1 2/3. So just because the numbers come a certain order in the problem does not mean that's the way we'll use them. Once again, read your words. We should probably write our words. Okay. Now we have a division problem, but again, we need to go to improper. 2 times 2 plus 1, 5 halves. 3 times 1 plus 2, 5 thirds. Division can become multiplication by using the reciprocal. These 5s cancel. That leaves me with 3 halves, which is 1 1/2. So 1 1/2 cup of flour for every 1 cup of water. On page 41, a baker uses 3/4 teaspoon of yeast and 1/3 cup of warm water to make rolls. How many teaspoons of yeast does the baker use in 1 cup? And so this time they decided to show us with a double number line, 3/4 for 1/3. If you double 1/3, you get 2/3. So double 3/4, you'll get 6/4. And if you take 1/3 times 3, you'll get 1. And 3/4 times 3, you'll get 9/4. So you could do that. I generally don't think of it that way, but you can absolutely do something like that. On page 41, in the example, what is 3/4 divided by 1/3 the unit rate for? So let's look at the 3/4 is for teaspoons of yeast. 1/3 is for a cup of water. So teaspoons of yeast per cup of water. Part B, the baker fits 26 rolls onto a pan that measures 1 5/8 feet squared. How many square feet does the baker use for each roll? So if our total is 1 5/8, and we're looking for square feet for each roll, square feet for each roll, that will help us to put our numbers in the correct place. 1 5/8 square feet for 26 rolls. What would that be for each roll? Well, again, let's change our mixed number to improper. 8 times 1 plus 5. 13/8 divided by 26. 13/8 times 1/26. I'm going to use cross simplification. 13 goes into itself once and into 26 twice. 1 times 1 is 1. 8 times 2 is 16. 1/16 square foot for every 1 roll. Number 2. Kenji mixes 1/5 pound of clay soil with 1/8 of a bale of straw to make an adobe brick. How much clay soil will he need to use the whole bale of straw? So we've got clay soil for a whole or 1 bale of straw. So we need our clay and then our straw. 1/5 of a pound of clay, 1/8 of a bale of straw. 1/5 divided by 1/8 is the same thing as 1/5 times the reciprocal, 8/1, 1 times 8 is 8. 5 times 1 is 5. But because it's a word problem, I'm going to make that a mixed number because it will make more sense, I think. So we could say 8/5 of a pound of clay for 1 bale of straw, but I'm going to say 1 3/5 pound of clay for every 1 bale of straw. Number 3. The soccer field at a park is 9,000 square yards. The soccer field takes up 6 2/5 square inches on the map of the park. How many square yards does 1 square inch on the map represent? So square yards per square inch. So my yards, 9,000 square yards, 6 2/5 square inches. And again, we're going to need to change our mixed to improper. 5 times 6 plus 2. Now some people like to put that over a 1. You can, but you don't have to. Multiply by the reciprocal. And in this case, I don't know if 32 goes into 9,000, so I am going to go ahead and do this one on a calculator. Calculator gave me a decimal. (1,406.25), which would be the same thing as 1,406 1/4 square yards for every 1 square inch. And last one for today. At top cruising speed, a mako shark can swim 4 kilometers in 1/10 hour. A blue whale can swim 5 kilometers in 1/4 hour. Which animal swims faster at top cruising speed? And how much faster? So we're talking about speed. We're going to go kilometers per hour. We've got a mako and a blue whale. If you have a guess, go ahead and say what you think your guess is. Four kilometers in 1/10 of an hour versus 5 kilometers in 1/4 of an hour. Why don't you go ahead and figure those two out? I hope you got 40 kilometers per hour for the mako. And so I have room to write 20 kilometers per hour for the blue whale. So which one swims faster? The mako is faster. And then it also asks us how much faster. I'm going to say by 20 kilometers per hour. I could also say that he was twice as fast as the blue whale. Okay, that's all for today. Thanks for watching.